Hold on. What if everything you've been told about our world is turned on its head? At first glance, the flat Earth theory might sound like a clever twist on reality. But when we dive into the science behind rockets, flight paths, and even the way shadows behave, one thing becomes crystal clear. Our planet is a globe. Let's start with rockets. When a rocket launches, its flight isn't a straight upward shot. It follows a curved trajectory. This isn't a quirk. It's a deliberate path calculated to match Earth's curvature and work with gravity. Every launch is meticulously planned using the principles of spherical motion. Imagine a rocket curving gracefully over a round horizon. That's modern physics in action. Now consider airplane routes. Airlines don't chart straight-line paths on flat maps. Instead, pilots rely on great circle routes that account for Earth's curvature. When you see a flight path stretching across a globe, it becomes obvious that the shortest distance isn't a straight line on a flat surface, but an arc along a sphere. This isn't just theory. It's built into our navigation systems and everyday travel. Then there's the case of shadows. Ancient scholars like Eratosthenes noticed that at different locations and times, the length and angle of shadows shift. He even used these observations to calculate Earth's circumference centuries ago. Fast forward to today, and we see that modern experiments, including time-lapse observations of shadows, reinforce this idea. Shadows vary in a way that only makes sense if the Earth is curved. Critics of the flat Earth theory often claim that photos and data from space are faked. But look closely. The consistency across multiple independent lines of evidence, from rocket launches and flight navigation to simple shadow measurements, forms a compelling case for a round planet. When science from various fields converges on the same conclusion, it becomes hard to dismiss as mere conspiracy. Think about the horizon. Stand on a beach or atop a mountain, and you notice that the curvature of the Earth is subtly visible. High-altitude balloon footage, which many independent enthusiasts have captured, shows a gentle curve that would be impossible on a flat plane. Whether you're watching a rocket ascend or boarding a long-haul flight, the data and everyday experiences tell us one story. Now, why do some cling to a flat Earth despite this overwhelming evidence? It can be tempting to believe in alternative explanations when they promise secret knowledge or challenge the status quo. However, critical thinking means examining the evidence from every angle. When experiments, historical records, and modern technology all point to a spherical Earth, skepticism should lead us to ask, which evidence is more credible? The anecdotal claims or the reproducible scientific measurements? In our journey today, we've seen how rockets follow curves dictated by gravity, how flight routes trace the globe, and how the play of light and shadow offers a natural experiment that has been repeated over millennia. These aren't isolated facts. They're interconnected pieces of a vast scientific puzzle that confirms our world's true shape. So, whether you're an avid follower of scientific inquiry or just curious about the debates swirling around you, remember that real science isn't about persuading us with flashy ideas. It's about consistently testing, measuring, and confirming what we observe. The evidence from physics, astronomy, and everyday phenomena all converge on one undeniable truth. Our planet is a magnificent, spinning globe. Keep questioning, exploring, and demanding evidence. After all, true discovery starts with curiosity and a commitment to the facts. Let the light of science shine on every shadow of doubt. Thanks for joining me on Thinking Scope. Hit subscribe for more dives into life's big questions.